Now, suppose the question says, solve the following differential equation using Laplace method. Y prime plus y equals to sine x. Y at 0 is equal to 1. So what are we going to do? We're going to take the Laplace of every term that we have here. It's just an operator. So it is equal to the Laplace of sine x. So what's the meaning of that? It means that here we have the Laplace of the derivative, which by definition is s, f of s minus f of 0 plus Laplace of y, which is just f of s, equals to, well, here you have the Laplace of sine x, which becomes 1 over s squared plus 1 squared, or just 1. Very well. F at 0 is equal to 1. So s of fs minus 1 plus f of s is 1 over s squared plus 1. So here, if you add 1 to the other side, this is s plus 1 f of s equals to 1 over s squared plus 1 plus 1. So what are we going to do? We're going to isolate f of s on one side. F of s becomes 1 over s squared plus 1 times s plus 1 plus 1 over s plus 1. Now, to find f of s, we just need to find the inverse Laplace of each of these terms. Y of x becomes the inverse Laplace of 1 over s squared plus 1 times s plus 1 plus inverse Laplace of 1 over s plus 1. Very good. Now we need to solve each one of these separately. Okay, let us solve this one by one. The inverse Laplace of 1 over s squared plus 1 times s plus 1. First of all, we need to write this as two fractions. The first fraction is a over s plus 1 plus bs plus c divided by s squared plus 1. Or you could just try your best to identify what are the values for these. So here, as squared plus a plus bs squared plus cs plus bs plus c must be equals to 1. So what's the meaning of that? It means that a plus b is 0, c plus b is 0, and a plus c is equal to 1. Very well. So a is negative b, c is negative b. So negative 2b becomes 1, or b is negative a half. So a is a half and c is a half. So we found these values, a half and a half. So these are the fractions that you're working with. A half, negative a half, s plus a half. So we separate these using partial fractions. Now, we need to calculate the inverse Laplace of each of these fractions separately. Very good. So with this one, you get a half e to power negative x. And again, if we divide this up into two more fractions, plus a half divided by s squared plus 1, this guy becomes, well, negative a half cosine x, and this is plus a half sine x. So the answer to this inverse Laplace is a half. So my y becomes so far a half e2 minus x minus a half cosine x plus a half sine x. And here you have plus the inverse Laplace of 1 over s plus 1 is nothing but e to power negative x. So we found a particular solution for this differential equation, which is written this way. Of course, you can simplify this more. Y of x becomes 3/2 e2 minus x minus a half cosine x plus a half sine of x, which is the solution of the initial value problem. Y prime plus y equals to sine x, y at 0 is 1.